এখন যে প্রেজেন্টেশন দিবে উনি কি আসছে? হ্যাঁ
13 নম্বর স্লাইড।
হ্যাঁ জানো 13 নম্বর স্লাইড, 13 নম্বর দেখো তো উনি আসছে কিনা।
প্রেজেন্টার আসেনি। জানি না
কে কোনটা?
গ্রাফিনাম সাইড।
গান
গ্রাফিনাম সাইড আপনাদের তো 13 নম্বর, তাই তো?
আছেন, আপনারা আছেন?
পরে লাঞ্চের আগে পরে কথা বলছি।
লাঞ্চের পরেই হচ্ছে।
লাঞ্চের পরের সেশন যেটা আছে সেটা গ্রাফিনাম সাইড দিয়ে শুরু হবে। মিডি মাইক্রোবিয়ালের ফ্লোর দেওয়া হয়েছিল, ওনারা আসেনি।
আচ্ছা আচ্ছা।
সেই কারণে আমরা এটা কন্টিনিউ করি। লাঞ্চের পরের সেশন আমরা শুরু করবো।
আইসিটি 13, আপনার আইডি কি 13?
হ্যাঁ হ্যাঁ ওরা
জি জি 13 থেকে শুরু হবে।
প্রথম ডাই স্যার।
ঠিক আছে।
প্রেজেন্টার আসেনি তাহলে বলতে পারতেছি না।
এবং দেখো যে সবগুলা প্রেজেন্টার আছে কিনা ফয়সাল, সবগুলা প্রেজেন্টার আছে কিনা।
বন্ধ হয়েছে? হ্যাঁ হ্যাঁ না আসেনি আসেনি আসেনি।
হ্যাঁ হ্যাঁ আমি ওইটাই করার চেষ্টা করছি। আচ্ছা
স্যার স্লাইডস এখন আসতেছে না। ও ওয়েট ওয়েট ওয়েট
একটু চেক করে নিচ্ছি আপনাদের সাথে যে যারা প্রেজেন্ট করবেন তারা উপস্থিত আছেন কিনা, জাস্ট একটু কনফার্ম করেন। এমনি মোস্তফা রাফিদ আছেন? মোহাম্মদ আইনাল হাসান আছেন? সাদমান সাদিক, অরুণ কান্তি গুহা, অরুণ কান্তি না এখনো আসে নাই। মাহমুদুল ইসলাম, এটাই তো। এমডি বশিরুল ইসলাম, দুইজন নাই। এটা কি দেখাচ্ছে? অরুণ কান্তি গুহা আছেন নাকি অন দা ওয়েতে আছে জানি না, একটু মার্ক করে নেন। 16 আমরা সবাই বসে পড়ি। মাহমুদুল ইসলাম আছেন? দুইজন তো নাই। এইটা এই যে অরুণ কান্তি আর মাহমুদুল ইসলাম 16 এবং 17, 16 এবং না আমরা শুরু করে দিচ্ছি। ম্যাডাম আপনারা এই দুইটাই মাঝে 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 ওইখানে বসে দেখতে পাবেন না, এখানে এখানে চলে আসে, চলে আসে।
16-17 নাই তাই তো?
16-17 নাই,
13-14-15 আছে।
13-14-15 আছে এক্স্যাক্টলি। সবাইকে একটু বসার জন্য অনুরোধ করছি, আমরা এখনই সেশন শুরু করব। Okay, hello to all and welcome back after the break. I welcome you all again in the technical session 3, and I hope that is you will all enjoy the session like you did before the break. So for session 3, technical session 3, our session chair will be Professor Dr. Nargis Jahan Aram, and our co-chair will be Professor Dr. our co-chair will be Dr. Sheikh MD Mamunul Kabir. Okay. So I would request the session chair and co-chair to start the session. Mic then.
Hello, ঠিক আছে? Hello, a very lovely good afternoon to everybody. Welcome to our technical session 3. I am Professor Dr. Nargis Jahanara, Dean, Faculty of Science and Engineering. I am going to act as a chair of this session along with my co-chair Dr. Mamun Kabir. Now, I think it will be an interesting session with waste management, biotechnological method, and various current affairs. So enjoy our technical session. At first, I request Mr. Mustafa Rashid to present his presentation. Mr. Mustafa Rashid to present his presentation. Mustafa Rashid, yeah. Oh. Excuse me, for all presenter, your time limit is 20 minutes, including 5 minutes for questionnaire session. So you are getting 15 minutes for presentation and 5 minutes for questionnaire session. Thank you. Okay, let's start.
Assalamu alaikum. Thanks everyone for giving me an opportunity for presenting my paper. My paper title was Graphene Oxide Chitosan Nanocomposite and Effective Solution of Methyl Orange Dye Removal in Finishing Wastewater. Methyl orange, which is very much used in leather and textile industry, but it's also an anionic dye. Methyl orange used for its bright color and stain materials, but it has some causes, that is its erosion and redness. When it's leaching, it made red eyes, and when it made it with eye contact, it made discomfort with others. Graphene oxide. Graphene oxide is derivative from graphene, which is graphene oxide has much oxygen containing functional group, and among them hydroxyl and carboxylate, etc. These 5 functional group have both electrostatic fraction and hydrogen bond. Among them, pi stacking and aromatic ring are used for their absorption capability. But for a slow recovery from water, we need to modify its surface structure. Chitosan. We used chitosan, that is derivative from shrimp shell. By shrimp shell, here we produced chitin. It is 14 to 30%, and protein, that is 40%, and mineral, that is 35%. The shrimp shell, it also have nitrogen and oxygen containing functional group that converted, when it is converted into chitosan, that made rich polysaccharide. This polysaccharide that derived much anionic pollutants from water. Our main objective is to produce a nanocomposite from graphene oxide and chitosan, and made it usable for remove methyl orange from finishing wastewater, and also its effectiveness from the water. our main materials is chitin and graphene oxide. And this chitin is derivative from shrimp shell. The procedure of making graphene oxide, we produced it by reduced hammer method. Then at first the graphite flakes, the sodium nitrate and sulfuric acid used in ice bath. Here the temperature was 2 to 5 degrees Celsius. We try to maintain this temperature under 5 degrees Celsius, and then added potassium permanganate. Also then the heated and distilled water added them. But the temperature, when the temperature increased, we try to maintain the temperature under 70 to 80 degrees Celsius. After cooling that, we added hydrogen peroxide, and after repeatedly wash, we try to maintain the pH 7, and then after calcination it and made the graphene oxide properly. It's the procedure of our maintaining graphene oxide. That is the chitin. We try to produce chitin from shrimp shell. The shrimp shell, then preservative, then we try to break its cell, then mineralization, and then filtrate it, try to neutralize it also. Then after deproteinization, we try to filtrate it until the pH 7, and then after deacetylation we produce the chitin, and after drying we use this chitin. Is the procedure of our making chitin. And when after nanocomposite procedure, we used chitin and graphene oxide both sonicate with differently, and then we try to use hydrothermal reactor and made the composite with 5 different ratio, where our control was just graphene oxide. And then the composite used, we try to use this composite as batch absorption process, and we use this methyl orange, and after treatment we receive that type of water. It's a result of our FTIR image. That is, at first we noticed that for graphene oxide there are some peaks when arrived 1735 and 1628, but those peaks are not in the nanocomposite. Also for chitin 1662 and 1560, these peaks are not available in the maintaining composite, so they are in bonded forms. They are easily say that. The XRD image of our composite, that is, for the graphene oxide we give the 2 theta degree is 9.78 degree, and for the chitin we received 9.52 and also 19.73. Whether for our nanocomposite it comes 9.65 to 9. And also 19.88. These peaks indicate the nanocomposite forms directly. It is the ACM image of our composite. That is, first image A is the graphene oxide sheet forms, and the second image is the chitosan. That is, we produced also the SIG image, that is the nanocomposite image. That is, both graphene oxide and nanocomposite are chemically bonded. It is the UV analysis of our composite. That is, for graphene oxide we gave 230 to 235 wavelength. For this wavelength, pi to pi excited pi and carbon-carbon excited bond are attached. Also for neutron to pi excited bond are attached. For the chitosan we found 240 to 280 nanometers peak, and for the graphene oxide we received 220 to 250 degree nanometer peak. is the result of for our effect of dose. We maintain 4 parameter for our batch absorption method. That is, first of all, the effect of dose. For the effect of dose, we try to maintain that every dose gap 0.1 gram per liter, and we try to made it from 0.1 to 0.1 gram, and for this the optimal dose comes 0.5 gram per liter. After adding furthermore, then the efficiency is not higher. For 0.5 gram we received 96.099% methyl oxide removal. For the effect of pH, we try to maintain it, start it from 3 to 12 pH, and from 3 to 6 the efficiency goes up, and the optimum pH comes at 6, and further increase the pH, the efficiency goes down, and for pH 6 the efficiency was 97.84%. And for effect of stirring, after stirring from 10 to 16 minute, 10 to 60 minute, we received for 10 to 35 minute the efficiency was increased, and after that the efficiency doesn't increase so much. So our optimum stirring time was 35 minute, and for 35 minute the efficiency was 97.84%. Is the absorption isotherm of our graph. That is, know that Freundlich and Langmuir we used here, and for the Freundlich the R square value comes at 0.99.12, and for Langmuir the R square value comes 0.856. Whether Freundlich absorption is related to our work, and for Freundlich we can say that here multilayer absorption formed, and for the Langmuir absorption it is where Langmuir absorption shows the single layer absorption. Whether our work is correlated with Freundlich absorption, so we can say here multilayer absorption forms. Also we show here the absorption kinetics. The absorption kinetics we used here pseudo first order and pseudo second order absorption kinetics model, and we know that pseudo first order kinetics model is used for Fiji absorption, and pseudo second order kinetics model is used for chemi absorption. And whether for pseudo first order kinetics model our R square value comes 0.77305%. Also for the pseudo second order kinetic model the R square value ups to 0.98%. So you can say that here chemi absorption formed. Is the comparison table of our work. That is, for our work this type work is also worked previously, and for our work the removal efficiency comes higher to 97.84%, and for another methyl orange removal percentage here both are lower than us. Thank you. Yes.
So this time
Yes.
is question times.
Okay, now the floor is open for question. You can ask any question.
Mustafa Ravid,
Yes.
please go to your introduction. Title.
Yes.
Here you produce a nanocomposite to remove methyl orange dye.
Yes.
My question is, it is viable to produce a film or membrane for water treatment?
Say it again.
Is this possible to produce membrane and
Yes,
film
yes, yes.
by this graphene oxide and ketosene nanocomposite for water treatment?
Actually, we produce here as absorbent, and we use here as batch absorption method, and for our paper we try to make it a filtrate method. We try to filter paper, and between them the nanocomposite ports, and then the pressure applied for the absorption, and it may happen for the membrane.
Okay, I got it. You already produced a membrane, right, film,
No, I just produce a nanocomposite. That's not membrane.
on a filter paper.
Yes.
Okay, I got it. Thank you.
I have one question, Mr. Rafid. You use the methyl orange for removal of the, the dye stuff.
Yes,
so why you don't use the other dye stuff like reactives, discards?
Sir, we used methyl orange. For methyl orange is anionic dye, and graphene oxide and chitosan both have some cationic functional group. We try to use them. So though we know that we try to use this chemi absorption then. So we try to the chemical bonded form. So we choose anionic dye, and whether methyl orange is very popular as azo dye in textile and leather industry. So I used methyl orange.
And could you show us the UV absorption spectroscopy?
Sure, sir.
So this is the usually when you prepare the ZOCS nanocomposite, this absorbent. So for the removal of the dye stuff, there is also need to analyze the
Yes, sir.
absorption.
Yes, sir. Yes, sir. We made it. We already have done this test, and in the paper we try to in paper we always maintain 4 graphs, that is before the application and after the application, sir.
Okay. Did you measure the XPS analysis?
No, sir. XPS analysis, we made it XPS analysis also in SEM, and also the size of dye stuff in our after application, and we didn't show it there, but we show it in paper.
But in case of the nanocomposite, when we want to measure the nanoparticles, we
Yes,
need
sir.
to analyze the transmission electron microscope, not SEM. SEM only
FESEM,
measure the-
sir.
yeah, yeah.
FESEM, sir.
The FESM also measure the only microparticles, not nanoparticles. So I don't know why you choose the scanning electron microscope for analysis.
Sir, actually we used SEM for analysis the pore before and after use, both though it have also chance for Fiji absorption. So for analysis the pore we used the SEM image.
Okay, thank you very much.
Okay, Mr. Rahid, I have a question.
Yes, ma'am.
Have you measured desorption rate or intraparticular diffusion?
No, ma'am. It's preparing. It's my thesis project.
Going on.
And when I complete this project, inshallah, I will
But
make
you
it.
have to complete the project, you have to, I think, measure the desorption rate,
Yes, ma'am.
intraparticular
Yes, ma'am.
coefficient, and also you have to think about the disposal after absorption.
Yes,
or
ma'am.
absorption.
Ma'am, we also try to make it is it biodegradable or not. Also, it's antimicrobial test where it's preparing for its antimicrobial test and its biodegradability. We are checking for it, and so that though it's in testing period, so I didn't add it here.
Okay, thank you, Mr. Rafid. Any question?
Hello.
Yes, sir.
Thank you very much for your presentation. So first I have objection about the writing finishing wastewater. Why have you written finishing wastewater? In the finishing department or finishing section of dyeing industry, we cannot use dyes. So why you have written finishing wastewater?
Sir, dye is used in, we thought dye is used in finishing part of textile and leather.
You can tell that not it is used in the dyeing machine,
Dyeing-
not in the
dyeing
finishing
industry.
department. In the finishing department is another chemical, maybe
Yes, yes.
some softener, maybe some other finishing chemical. Number one. Number
Yes,
two,
sir.
you have mentioned in the abstract that methyl orange is a toxic carcinogenic.
Yes, sir.
And for sure, you should be sure that toxic carcinogenic could be used maybe in the past, but not in the present. Now the buyers are so many, they are very much sensitive, and there is RSL, restricted chemical substance list. So maybe you can check whether this methyl orange is still being used in the textile industry or not. And another thing is, we cannot use the single shade. So and it is anionic dyes, so maybe trichromatic combination you use in dyeing. So there is another also anionic dye. So what will happen about that dyes? And
So-
also the methyl orange, it does not be being used widely.
Sir, whether we analysis in our research period for analysis the topic, and methyl orange is very much
Can you give me any brand names of methyl orange dyes? Any brand names?
azodye used
No,
in-
as is a generic name maybe, but any commercial
Commercial.
dyes where this methyl orange have been used.
no, sir. Sorry, sir. And
Okay, thank you.
Okay, actually, sorry to interrupt. We have not enough time to interact. Thank you, Mr. Rafid, for your
Yeah.
presentation. Now, I request second presenter, Mohammad Ayman Hassan. Mohammad Ayman Hassan to present his presentation. PBO fiber synthesis, sustainable approach to PBO fiber synthesis. Important fiber having high thermal stability and tenacity. So, Ayman Hassan going to present his presentation.
Assalamu alaikum. Have you ever imagined a fiber 9 times stronger than the steel also can be produced from waste material? Walk with me and you will get the answer. I am presenting our paper titled Sustainable Approach to PBO Fiber Synthesis Utilizing Chemical Industry Waste for Sustainable Fiber Production. This is a theoretical framework. We proposed a method of producing PBO fiber utilizing industrial wastewater, and we haven't conducted any experiment regarding this study. Myself, Mohammad Ayman Hassan, I am from Department of Food Process R&D, Pacific Jeans Limited, and my co-authors are Famida Alam Sharif, Hirogami Kazumasa, and Abu Yusuf Muhammad Anwar Lazim. I express my greatest expression. Thank you for giving us the opportunity to present our study here. Now let's get to the presentation. The content of the presentation is introduction, objectives, methodology, assessment, result, why PBO fiber, environmental benefit, and conclusion. So, what is PBO fiber? PBO full form of polybenzobisoxazole dial phenylene is a man-made fiber that stands out as an ultra high performance synthetic fiber. Ultra high performance means remarkable strength like tensile strength, tensile modules, elongation break, and superheat resistance up to 650 degrees centigrade, tensile strength 9 times greater than the steel by weight, excellent resistance to abrasion and chemicals. The PBO fiber originating from Toyobo Company Limited in Japan as an Xylon fiber. The application is in aerospace, space elevator research, military body armor, bicycle, wheelchair, motorsports, conducting textile, loudspeaker, structural rehabilitation, high altitude balloon science and parachutes, and many more. Why are we doing this study? Our goal is PBO fiber production utilizing industrial waste materials, paving a path of PBO fiber production for sustainable processes, and diminishing environmental footprint, reducing reliance on raw materials, further contribute to future study. Now let's get to the methodology part. Here we should first collect industrial wastewater and recycle through bipolar membrane electrodialysis BMED, as you can see in the figure. At the first, the wastewater should produce introduced with carbon dioxide to produce aniline, charged aniline, so that we can separate the aniline from in BMED chamber, and additionally sodium hydroxide and buffer solution are also used in this chamber for pH maintenance and acceleration of aniline separation. After the separation, the distillation should be done. After we get the pure aniline, aniline should react with hydrochloric acid and sodium hydroxide at low temperature to produce diazonium salt, and further with copper chloride and hydrochloric acid at the same temperature to synthesize chlorobenzene, and further introduce chlorine gas at 60 to 100 degrees centigrade in the presence of iron ferric chloride to produce 1,2,3 trichlorobenzene. After that, trichlorobenzene should nitrate to produce trichlorodinitrobenzene. By further reduction, we can achieve dinitroresorcinol. And now, as a standard procedure, dinitroresorcinol should react with terephthalic acid at the presence of polyphosphoric acid in 160 to 200 degrees centigrade to produce PBO polymer. After that, we should use dry jet wet spinning for producing PBO fiber from PBO polymer. Here we should check pressure temperature sensor for suitable fiber production, and we should clean multi-hole spinneret, and after the production we should go provide it to heat setting for dimensional stability of PBO fiber. After the production of PBO fiber, we should assess with FTIR and SEM and EDX and tensile testing for its mechanical and physical properties and surface visualization, and we should also identify PBO fiber by its chemical bonding and element identification. As we go through this process, we anticipated that the properties of this PPO fiber should be tensile strength from 5.3 to 5.8 gigapascal, and elevation break should be 2.5 to 3.5%, and tensile modules will be 180 to 250 gigapascal, Ictse modules 380 to 450 gigapascal, and tensile elongation 1.5 to 1.7%. Nowadays, as a reversed fiber, widely used Kevlar fiber. So we present a comparison between PBO and Kevlar, so that we can know that why PBO fiber is better than other fiber. Here we can see that the tensile strength of PBO fiber is much higher than Kevlar, and in case of elongation break, the PBO fiber is slightly lower than Kevlar fiber, but the value maintains is standard. In case of tensile modules, PBO fiber is slightly higher than the Kevlar fiber, but in heat resistance, PBO fiber shows noticeable difference compared to Kevlar fiber. In this method, we have some environmental benefit, like recycling aniline from wastewater. Aniline has a significant hazardous to an human health and environment for its prolonged resistance to biological element. It is a priority control pollutant by US Environmental Protection Agency, and in this method no additional effluent treatment should needed to be done, no secondary pollutant is produced, and it is maximized its resource efficiency. Overall, this theoretical framework presents an innovation and suitable approach to PBO fiber production. It laid the groundwork for future experimental investigation to validate the proposed method and optimize the production process. Successful implication of our synthesis method will contribute the development of more sustainable practices within chemical industries. The potential application of PBO in diverse field underscores the broader impact of our finding. And last, we can say that a waste isn't waste until we waste it, as William says. Thank you.
Thank you very much, Mohammad Ayman Hassan.
Yes, sir.
Any question from audience?
Just I want to know,
Yes.
is this a road method?
Yes.
You invented this synthetic method?
Yes, actually the PBO fiber is nowadays produced from two ways, one from 1,2,3-trichlorobenzene and another from resorcinol. So we use aniline to produce 1,2,3-trichlorobenzene and follow the same process.
Was
So
it your own idea?
yes, my own idea.
You implemented it?
No, I haven't implemented it. This is a theoretical framework. I haven't conduct any.
Theoretical?
Yes, sir.
It's not.
It's not
Practical activity?
no, sir.
Oh, so who researched it?
So Mohammad Ayman Hassan sir, is your suggestion, right?
Yes, sir. This is a proposed method.
So how can you, how can you how can you get the aniline from the industry waste? How can you get?
The industrial, as an industrial like chemical industry and dyes industry, they have lot of industrial wastewater and aniline rich wastewater. We should collect this wastewater.
But
So-
this is the mixed water. there are several chemicals actually mixed together and we
Yes.
throw it, right?
Yes,
So how?
Aniline content is so high,
yes.
you can use it as raw material.
And I am using in the recycling area to separate the aniline from the wastewater, other than this leaving the other chemical with the water.
You presented your paper in a way that you have carried out this work yourself. You analyzed the materials, tested the materials.
No.
You used high technology, This is what I'm saying.
No.
This is
I
only-
said this should be.
Imagination.
No, I said this should be done, and
It should be done.
yes.
Is there anybody who has validated your process?
Actually, I
Thank you.
actually
Actually, it is very nice, nice topic.
Yes, sir.
And but the problem is the implementation. So my first question is there any people or anybody who has validated your process? Because it is a chemical intensive process, and yeah, it is also harmful. So who has validated your process?
I actually
We can imagine so many things. We
I
can imagine so
contacted
many
with
things.
our corresponding author Anwar Azim Konok sir, who is now a PhD candidate at Japan University of Fukai, and he also show this work to his professor Hirogami Kazumasa sir, and he also validate it like a proposed method.
And I am also interested to know about the conventional process of making PBO, and with your dreaming one, with some experimental data, maybe how much energy you used,
Yes.
and with the conventional one.
In case of experiment, there will be lot of changes and lot of factors should be considered, and in future I am actually hoping to experiment it by practical, but at this moment I am unable to. I haven't got any opportunity to carry out this experiment, because this is so much high energy needed for this experiment.
Okay, thank you.
Okay, Mohammad Ayman Hussain, we don't have enough time. Thank you for your presentation. Okay.
Thank you.
The next presenter is Mr. Sadman Sadiq, and his topic is conversion and characterization of biodiesel from tannery solid waste.
In this axis, which is that?
Okay. Assalamu alaikum everyone and good afternoon. So today here our topic is conversation and characterization of biodiesel from tannery solid waste, and here I am Sadman Sadiq, and me and my co-author from Khulna University of Engineering and Technology, Kuwait. So at first we see here our statistics from Petro Bangla, which is produced from 2022, and here our shows our energy consumption in Bangladesh and per day. If you calculated the supply and demand, per day deficit approximately 1288 million cubic feet. And within 2026, Bangladesh will go through a middle income country. That's why we cannot take an advantage when we imported the oil or fuel from Middle East or Russia. So we have an energy crisis and we have to think concern about that. So it's a problem. So now our another problem is the Bangladesh, the second largest export sector is leather and leather products. And if we focus the Savah tannery estate, they are already set up 300 more tannery, and which has not the ability to treat the wastewater, because most of the waste it may solid or liquid, and there are only CETP which is made by BUET, but it cannot run well properly. That's why it's a burden for the CETP authority. And we have also concern because it creates the health diseases, imbalance of aquatic life, and also the environmental parameter disorder. So it's also a problem. So we merged these two problems and proposed a solution to produce biodiesel from this solid waste, which may reduce the energy crisis. So why solid waste? Interesting information, if we produced 1000 kg leather production to intention to go to the tannery, and only we can get 150 kg approximately the final output, and more than 850 kg is just waste. So it's a burden because we have not the proper capacity, and only the famous method to treat the solid waste is landfilling, and it also pollute the land condition and the groundwater, so it has another concern. So we have to find out the another approach to solve this problem. That's why we focus the how much the waste produced. There are a statistic, and we said that fleshing is the second largest waste, which is produced 120 kg per 1000 kg leather production. And first of all, the fast solid waste may salt when we go to the solar extraction. Okay, so what is the fleshing process? So fleshing process is a beam house operation, and it may done also the mechanically or manually to remove dirt, flesh, and any kinds of unwanted things from the hides or skin. And from this process we will get the fatty waste. So why fleshing waste? Because if we focus the continuants in this waste, we can see that 86% has the fat and grease. That's why we focus these types of waste. It is our overall framework. At first, the slaughtering house, we will go through the beam house operation, which you can say it tannery. After that, we will go through our fleshing operation, and next, transesterification is done by the waste animal fat and extracted biodiesel, which may be used in various purposes. Our objective is very simple: to produce biodiesel from tannery waste and to evaluate the physiochemical characteristics and what will be the expected output come from this. Now it is our methodology. At first we collecting the fleshing waste from our tannery, which is situated at Joshua district, Ictse Group of Industries Limited company. Then first of all, then we dry it and clean it and use detergent for washing 15 to 20 minutes at 50 to 60 degrees centigrade temperature to remove blood, wool, and many unwanted contaminants. And drain out the excess water, then clean sample was get. Then main methodology, which is transesterification process, a very old process to extract the oil or fat to make fuel. clean sample, heating for 3 hours for 3 days at 200 to 250 degrees centigrade temperature, and catalyst reaction was done with the use of ethanol and the catalyst with sulfuric acid. And after, as a post treatment, heating for 2 hours and storing and cooling, then a biodiesel mixture we will get. So biodiesel mixture, there are two mixtures, which is biodiesel and the glycerol. To use of the separatory funnel, we extracted our biodiesel by the process of gravity separation. So what was our outcome? At first, we are measuring the chemical components, and our percentage of yield is 55%, and our iodine value is 105, and the normal value is 14.6. So our iodine value, it's maybe a reason because we only clean the surface. We think there are so much impurities at the inner structure that cannot be fully cleaned by the detergent when we are cleaned. So it may be a reason the higher iodine value. And higher iodine value indicates there are so many unsaturated fat is also already present in the waste sample. Then we are doing the flash point analysis, and our flash point analysis is 148, and which is good because it's a moderate range. If we lower flash point, then it may be a risk to produce or any other fire risk, and flash point is minimum temperature to ignite the well. Measuring the calorific value to estimate the how much energy formed, and our value is 39.7 megajoule per kg. And if we focus the biodiesel conversational and the normal diesel, and we can see the value 37.3 to 45.5, and our value is the range between them, so we can say that our oil is good. Next, FTR tests were done for identify the peak and the functional group, and here we functional group and the peak 2019-17 and 253 alkyne methylene group, and the carbon and oxygen from different bond and the peak were mentioned here. Finally, the physical properties of synthesis biodiesel were experimented. Specific gravity, viscosity and density in 3 parameters. Our value is near about close about our reference value. So our density is average 820 kg per meter cube. It made that it has a great flowability, and our viscosity is 3 centistrokes. And our relative density, which is specific gravity, is 0.89. So finally, our conclusion, we can make a biodiesel from solid waste, and because our lower flashing point means that it can be usable for engine fuel to ignite as so much fastly. And it was not the end task. There are the huge scopes, and we have also limitations. That's why we cannot take another experimented or doing or conduct furthermore. That's why in future life cycle assessment can be done. Gas chromatography also be a thing to conduct in future, and thermogrametric analysis can also to check the sustainability or quality under temperature. And it also a task because is it feasible to use in diesel or as a biodiesel in vehicle, and if we implemented the plant, and how to the possibility or the feasibility. That's why it can be a survey in future work. And the question can be raised of why the transesterification we choose, and there is a lot of technology already happened and more researchers work on it. It can be pyrolysis, hydrothermal liquefaction, and we are going through the transesterification process because it is versatile, it is low cost, cost effective, and it is easy. That's why it may be feasible for to doing in further if we can imagine. If you have any question, please ask, and thank you from myself. Okay. Good afternoon.
Thank you. Thank you, Sadman Sadiq. So, your topic about the biodiesel from the tannery solid waste. So, it's not a biodiesel, right? You cannot fix it right now. It's a biodiesel.
Because we are make it from the waste, and it can be full of no value when we cannot turn into a product. So when we waste to turn into a product, and it's generated from unwanted things which have no value.
How can you say it's a biodiesel?
Because it's normally that diesel is formed in many processes, and our conversation is something different, and the biodiesel is a concept from the to extract many sources which are not conventional actually. So on that perspective we said that it was biodiesel.
Okay, thank you. Any question from audience?
Thank you so much for your presentation. So, do you think your research is unique?
Because sir, we are thinking.
Is there anybody in the globe who has done the same experiment?
Yes, sir. Many other can be conduct this research, but they can use the fat to transesterification process. That process are same, but we can here to change or to add the novelty of this research. We will focus the tannery solid waste first of all. Second of all, we want to increase the percentage of yield, and we want to make it more optimized. That's why we can say that it is unique from others. But if you concern at the perspective of the methodology or the prospect, that is not unique, because transesterification process is so much old process.
Okay, and another thing is it cost effective?
Obviously cost effective, because
how much if you compare with the conventional and with your developed one?
Okay, sir. If you compare to three technologies, pyrolysis, hydrothermal liquefaction, and transesterification process, it may not use the huge equipments. It's a normal, and is it feasible to generate or make a plant? Otherwise, when we pyrolysis or the hydrothermal liquefaction, it may need to huge types of the reactor or the plant, or the initial cost is so much high. On perspectives, we may say that it's obviously cost effective.
And another thing, I have found that you have used sulfuric acid in your experiment. So I think, is it sustainable process? Or is there any alternative chemical which can replace?
Yes, sir. Obviously, alternative chemical can be used as a catalysis, because the sulfuric acid is fully acid, and when we want to try to reduce the percentage of catalyst the uses. You may say that this another acid or the catalysis you can also use, but it may occur that the percentage of the usable chemical is so much high. But when we use the sulfuric acid, the hampered or the negative impact can reduce also. But you are right that we have to try another solution.
Chemical, and also the people who will work with this acid may be affected. Also the environment
obviously, right.
Also will be polluted. That's why I'm telling that maybe it could not be the most sustainable way of making biodiesel. So, okay, thank you so much.
Hello. I am talking. Yes, sir. Have you measured you have told that it's a biodiesel, so have you measured any certain number, viscosity, surface tension, flashing point? Because if you want to use it as a biodiesel, you have to measure some diesel parameter, special diesel parameter. Have you measured certain number like this?
Ma'am, serial number was not measured because on the basics we may say that it was biodiesel because we compare it the conventional diesel and also biodiesel fat extracted but different sources. We compare it in 3 diesel and because our biodiesel is also fat extracted but tannery solid waste, so we compare the value, what is the difference and how much it bigger or lower. On the spectrum we are shows this result but serial number, carbon number and not measured.
Okay, thank you.
Actually, you're talking about solid waste,
Yes, sir.
the tanning, tanneries. But there are other solid components, say unhairy, the
Yes, sir.
shaving, this sort of thing.
Yes.
You consider only the fleshing. So what is this fleshing compost?
Sir, because there are a lot of
And fats.
yes sir, right.
So you are converting the fats oil, not the protein part.
Yes sir.
You carried out some sort of transesterification. What was that? How did you do it?
Oh, sir. Transesterification, sir, it's a process to break down the triglyceride to make fatty acid methyl esters, which is the primary component of biodiesel. And it is happened when the alcohol which break down the fatty acid chain with the help of the catalysis. And it is a process. And sir, you are right that there is so much protein.
You produce methyl ester of some fatty acid. It could be solid or liquid. Was it solid or liquid?
It's a liquid.
Transester, you should understand it. Triglyceride is an alcohol.
Yes.
So you replaced glycerine with methanol. So you obtain methyl ester of fatty acid.
Yes.
And that is suggested that can be used as a fuel for diesel. The biofuel, it's a biofuel. The alcohol, ethyl alcohol is a biofuel.
So as a byproduct, we obviously glycerol will produced.
That is why you call it biodiesel. Is it kind of fuel, right?
Right. Sir,
What
we
is diesel made of?
sir we are compare the value
Diesel, what is it?
is near about close about
What
the
is composition? Diesel.
But no, about chemical composition of diesel.
there's a difference in certain number, obviously the petrol octane.
Composition, I mean, mixture of hydrocarbon like this.
This is
Ob- ob-
organic compound,
Obviously hydrocarbon,
Organic
ma'am.
compound. Which category does it belong to?
Sorry, sir.
Is it aldehyde or it is saturated hydrocarbon or unsaturated?
Okay, okay, Sadman Sadiq, thank you for your nice presentation.
Thank you, everyone.
Now, you have a question? One more question, please.
Hello, thank you for your nice presentation. I have a question. Close to our university, there is a tannery for use solid waste for fermentation to produce biogas, methane gas out of it. What is the economic comparison to use this solid waste directly to fermentation to methane gas?
Sugar, I guess,
You make a comparison to that, because you have a very long steps, and fermentation should be easier.
Sir, obviously, sir, biogas can be produced also the solid waste, but here we focus on the particular waste and especially focus on those waste which has the large quantity about the fat contents. That's why we go through this process. But there are so many waste which may produce from the tannery waste, and they will go through the fermentation process and also make a huge amount of biogas. And there are some plant is already worked in this types of field work.
Okay, thank you very much. Now it's time for the topic about the conversion of waste to wealth by reusing rinsed water in knit dyeing. Mr. Arun Kanti Guho will present this topic.
Please, 1 minute.
Thank you very much. Respected session chair, other dignitaries, my fellow colleagues from home and abroad, good afternoon. I am Professor Arun Kantigo, working at the Department of Textile Engineering, Southeast University. I am very much grateful to the authority of Butex to give me such an opportunity to present our work. Actually, this is this work done by my students as undergrad research project. The title of my presentation is Conversion of Waste to Wealth by Reusing Rainwater in Knit Dyeing. Maybe it's not working. Please excuse me. Can you please help me? Okay, in sequence, I would like to explain first rationale of the study, followed by materials and methods, results discussion, conclusion, reference, and acknowledgements. Thank you. Okay, to clarify the problem of this work, what are scientific reasons behind the work we done? We know that all are textile engineers, I think, or students involved in textile industries, and we know that huge water is used, consumed in wet processing units, resulting production of effluent which harms our environment day by day. And another significant problem is in textile region, say in Gazipur, the groundwater availability drastically falls. In the slide, you can have a look from okay, in year 2011, the groundwater was available in Gazipur area just after at 26 meters and drastically fall to 51 meters in 2022. So it indicates huge groundwater we are that is using in our textile units. It's very alarming. So now what can we do, right? So we have to think. Nowadays, water saving technology and energy saving technology very important is textiles. So we have to think how can we reuse water. Okay. So our work was focused on reuse of rainwater. We know that huge water is consumed and we use rainwater, that is after dyeing several times. Water is several times dyed fabric washed or rinsed with in a huge amount of water. So huge amount of water is lost and it is just we was drained out. So it is a great problem, and our research focused on this rinse water, whether we can use reuse, whether we can do reuse of this rinse water. In the photograph, the first one, wastewater obtained from wastewater treatment plant. Normally this water is used in dyeing. And second photograph, rinse water. So both water physically is same. That is, in rinse water no color, so we can use. We try it in this work. Okay. We just collected rainwater from a famous textile industry of Bangladesh, Yarn Polar, sister concern of microfiber. And we also collected water from wastewater treatment, water treatment plant, which is initially used in dyeing. And we used both water to compare our dyeing quality. And in our lab in Southeast University, we have sample dyeing machine, eco dyer. We used our own machine for dyeing, and we have also a spectrophotometer, and we tried to interpret our results. Okay. Next slide, please have a look. Next slide consists of our, that is dyeing performance, color fastness to wash for 100% cotton. We use two types of fabric, 100% cotton and also 100% polyester. And in some cases we got better results. I don't say in every cases we got very good rating, but in some cases 3 to 4 rating we got in case of color fastness to wash. And we also compared with the dyed fabric with normal water obtained from water treatment plant. In case of 100% polyester, of 100% polyester, color fastness to wash, in some cases we got a good result, 3 to 4 rating. Next slide belongs to color fastness to rubbing for 100% cotton. And in case of 0.5 shade percent, we got 4 to 5 rating, which was also 4 to 5 with dyed fabric using water treatment plant, that is initial water. And some similar result obtained for 100% polyester also. Now spectrophotometric evaluation. In case of spectrophotometric evaluation, for 100% cotton, the CMC value, difference of CMC, that is as per CMC result, delta value obtained relatively higher. But in case of 100% polyester, D value, delta value, CMC value was within that is acceptable range. We know that less than 1 is the acceptable limit of spectrophotometric evaluation. So in this case we got good result. Okay, next slide belongs to K by S value. We know that K by S color strength, right? So in case of 100% polyester, we got significant color strength value, K by S value. And also in case of 100% cotton, except light shade, in medium shade and deep shade, acceptable values. So in conclusion, I like to say that we can use the reuse. We can reuse the reuse water. Okay, so we should not waste. We should think about water saving. How can we save our industry? How can we save our environment? So I propose for piloting of our project. It's just experiment, lab-based, lab scale work. So if we do any pilot scale, then we can solve the problem more. Some references. I am grateful to the authority of BUTEX Conference Organizing Committee to give me an opportunity to present this work, and also I am grateful to Southeast University for providing us a fund to do this experiment. Thank you very much.
Thank you very much, Professor Arun Kantigo. So any question from audience?
Thank you so much for your nice presentation. My question is it very difficult to use rinse water during dyeing, and do you think that the industries of dyeing industries in Bangladesh, they are not using this one? It is very difficult. So what is the solution? How to use this rinse water?
It is not difficult, yes, Dr. Fazil Rabi. It is not difficult, but as per our literature survey and as per our industrial experience, we saw that most of the industries just waste it. So we proved that it is not difficult to reuse rinse water by our experiment.
Okay, but how to use it? It must be stored in a way, maybe we need some mechanical support or
No.
machine modification.
Yeah. I think we don't need to store it because industry is a continuous process, So we can just, that is, reuse the rinse water by passing the water by using a pipeline. So we can easily use it without restoring. We don't need to restore, or we don't need to further treatment, because water obtained from water treatment plant, the pH was 7. Water obtained that is from the source of rinse water, pH was 7.4. Easily we can use it.
So do you think that in Bangladesh no industry is using your this rinse water?
Well, as per our literature survey, and I visited so many industries, most of the industries, I did not find a single industry who are using rinse water. So I focused on this work.
Okay, that's good information. Then maybe we can check it later on. Thank you so much. Thank you.
So, Professor Go, so I have a question about the, you use the rinse water, right, for dyeing. So what about the levelness after dyeing? Is there any complications? I think the rinse water means some of the dye stuff remain. Some dye stuff remain because actually for dyeing, polyester dyeing, there are several different methods. Reactive dyeing is different methods. So you use to the rinse water for the specific dye stuff, like a disperse dyes. When we dyed the polyester fabric, then rinse water we have to use again for disperse dyes, not for the reactive dyes, right? Am I right?
Yes, you are right. We used both dyes. We know that polyester dye, disperse dye is suitable, right? So for polyester dyeing, we use disperse dye, and for cotton fabric dyeing, we use reactive dye. So since two processes are different, so there is no specific complication in this dyeing, because polyester dyeing temperature, pH control, and also neat dyeing process flowchart totally different. So there is no possibility to get any complication in this system. And this is our experimental based, lab based work. We did not find any complication.
But I think the disperse dyeing process, it requires acetic media. So that kind of rinse water, if I want to use the reactive dyeing, so it may cause some problem.
Of course, you are right. In disperse dyeing, we use acetic acid, right? Acetic acid pH 4.5. Okay, but I mentioned the pH value is the indicative of any existence of acid or dye or alkaline material. pH was 7.4. Rinse water means after dyeing several times fabric was washed. That is, rinse water, almost all kinds of chemicals removed. So when we collected rinse water, no existence of acetic acid. Then we could not got the pH 7.4. If any acetic acid remains in the rinse water, then pH must be below 7. So 7.4 indicate there is no acid remaining in the rinse water.
Okay. Any other question, please?
আসসালামু আলাইকুম। হ্যাঁ, আসসালামু আলাইকুম। আমি বাংলায় বলতে যাচ্ছি। আমি ফ্রিল্যান্ড থেকে আসছি। আমি মেক্সিমোতে আছি। আমি মারুফ ইসলাম। তো রিঞ্জ ওয়াটার রিইউজ এটা আসলে প্রচলিত আমাদের এখানে, আমাদের টেক্সটাইল সেক্টর এটা আছে। কিন্তু এখানে কিছু কমপ্লিকেশন আছে। যেরকম আমরা রিঞ্জ বলতে কয়েকটা ধাপে বুঝি। যখন আমরা গ্রে ফেব্রিকটা ইউজ করি বা গ্রে গার্মেন্টস ইউজ করি, তখন আমরা একটা ওয়াশ দিয়ে নেই, ওইটা একটা স্টেপ হয়। আর আমরা যখন ডাইংয়ের পর ড্রেন করে দেই, ফাইনাল বা ড্রেন করে দেওয়ার পর ওইখানে একটা কাউন্টার রেঞ্জ হয়, কন্টিনিউয়াস রেঞ্জ। হ্যাঁ, তার মানে একটা ফ্রেশ বাচের রেঞ্জ পাচ্ছি, আর একটা হলো কিছুটা ডাইস বা কিছু কেমিক্যাল মিক্সড রেঞ্জ পাচ্ছি। তো এটার জন্য মেশিনে অ্যারেঞ্জমেন্ট থাকতে হয়, ডুয়েল ড্রেন লাইন সিস্টেম। একটা ড্রেন লাইন দিয়ে যাবে আমার সমস্ত ওয়েস্ট ওয়াটার, আর যেটা আমি রিইউজ করবো সেটার জন্য আলাদা একটা ড্রেন লাইন থাকবে, এবং এটার জন্য অবশ্যই একটা রিজার্ভার থাকতে হবে। কারণ আমরা যে কমন রিজার্ভার যদি আমি এই রেঞ্জ ওয়াটারটা নিয়ে ব্যাক করি, ওখানে আমার টিডিএস প্রবলেম হতে পারে। আমরা জানি যে ব্ল্যাক কালার ফাইন কাউন্টের ক্ষেত্রে টিডিএস খুব ইম্পর্টেন্ট, হোয়াইট কালার জন্য টিডিএস খুব ইম্পর্টেন্ট। তো কমন রিজার্ভারে এই রেঞ্জ ওয়াটারটা নিয়ে যাওয়া যায় না, ওটা আমার টোটাল পানিকে পলিউট করে ফেলতে পারে। এর জন্য আলাদা একটা রিজার্ভার থাকতে হয়। সেই রিজার্ভারকে আমার এই পানিটা রিজার্ভ করে পরবর্তীতে আমি আবার যখন ডার্ক কালার ওয়াশ করবো সেই জায়গাটা আমি এটা ইউজ করতে পারবো। কিন্তু এটার জন্য প্র্যাকটিস দরকার। আমাদের কনভেনশনাল যে অপারেটর আছে বা যারা লাস্ট 30 ইয়ার্স ডাইংয়ে কাজ করে আসতেছে, তারা এই জিনিসটা অ্যাডাপ্ট করতে চাচ্ছে না। আমি যেটার সাথে কাজ করতেছি, আমার ফ্যাসিলিটি আছে এই অ্যারেঞ্জমেন্ট। আমরা ওয়াশিং প্ল্যান্টে এটা ইন্ট্রোডিউস করেছি এবং হিউজ নাম্বার অফ ওয়াটার সেভ করা যায় 3টা বাথ থেকে। নর্মালি আমরা রিঅ্যাক্টিভ ড্যাঙ্গে জানি 12 or 14 বাথ লাগে অ্যাজ ওয়েল, বা মাল্টিফাংশনাল কেমিক্যাল ইউজ করলে সেটা আরও 3 বাথ কমায় আনা যায়। তো রেঞ্জ ওয়াটার রিউজ করে আমরা 3টা বাথের পানি সেভ করতে পারতেছি। বাট এটা চ্যালেঞ্জিং, বাট এটা পসিবল। বাংলাদেশে এটা হচ্ছে, অনেকে অ্যাডাপ্ট করতেছে। এটার জন্য বাজেট লাগে, একটা ভালো বাজেট লাগে। টোটাল সমস্ত ড্রেন লাইন আলাদা 2টা ড্রেন লাইন করতে হয়, পার্সোনাল রিজার্ভার লাগে, এবং টাইম টু টাইম ওয়াটার কোয়ালিটি চেক করতে হয়। কারণ এটা ওই লং টাইম ওই রিজার্ভারে প্রিজার্ভ থাকলে একটা অর্ডার তৈরি হয়, একটা গ্যাস তৈরি হয়। কারণ এটার মধ্যে কিছু কেমিক্যাল থাকে, স্যার যেটা বললেন, কিছু অ্যাসিডিক বিহেভিয়ার থাকে। আমি যখন রিঅ্যাক্টিভ বাথ ড্রেন করবো, এটার মধ্যে অ্যাসিড থাকবে। ওটা আমার কিছুদিন থাকলে কিছু কিছু ডাইস পার্টিকেল থেকে যায়, ওটার মধ্যে কিছু কালার তৈরি হয়, কিছু অর্ডার তৈরি হয়। ওটা ফ্রিকোয়েন্টলি ইউজ করতে হয়, ওটা রেখে যাওয়া যায় না প্রিজার্ভ করে। থ্যাংক ইউ।
না, ঠিকই বলেছেন, আপনার কথার সাথে আমার মিললো। আমিও ভ্যাকসিন করতে গিয়েছি, অন্য ইন্ডাস্ট্রিতে গিয়েছি, কিন্তু এটা আসলে ইন্ডাস্ট্রি ওনারা বুঝতে চাচ্ছেন না যে আমরা রেঞ্জ ওয়াটারটা যদি ইউজ করতে পারি, তা আমাদের
ওনারা চাচ্ছে, কিন্তু যারা প্র্যাকটিক্যাল ফিল্ডে কাজ করে তাদের জন্য অনেক ক্ষেত্রে চ্যালেঞ্জিং। তারা চাচ্ছে যে আমার ফ্রেশ ওয়াটার চাইলে আমি পাচ্ছি, তাহলে আমি কেন ব্যবহার করা পানিটা ইউজ করি? প্রোডাকশন এন্ড অফটাতে তার কোয়ালিটি মিট করতে হয়, তার কাছে কোয়ালিটি আগে।
কিন্তু এটা আমাদের মাথায় রাখতে হবে, গাজীপুরে পানির লেভেল 26 মিটার থেকে 51 মিটারে চলে গেছে। এরপর তো আমি পানিই পাবো না, তখন আমি কি করব? অতএব আমাদের এই জন্য আমরা রিসার্চটা শুরু করলাম। এখন ভবিষ্যতে আপনাদের সাথেও যদি কোলাবোরেশন হয়, তা আমরা আরো সামনের দিকে এগিয়ে নিতে পারি।
আমরা যারা সাস্টেনেবিলিটি নিয়ে কাজ করছি, এটা আমরা ক্যাম্পেইন করে আসতেছি, হোয়াই ইউ আর ইউজিং ফ্রেশ ওয়াটার রাদার দেন রেঞ্জ ওয়াটার। এটা আমাদের স্লোগান। আর একটা বড় অংশ যারা প্রোডাকশনের সাথে ডিরেক্ট ইনভলভ, তাদের কাছে ফ্রেশ ওয়াটার এত সহজলভ্য হয়ে গেছে, তারা এটা নিতে চাচ্ছে না। আশাবাদী হবে,
কিন্তু আর 5 বছর পর তো ফ্রেশ ওয়াটার পাবে না, তখন কি করবে?
তখন এটাই ব্যবহার করতে হবে।
এজন্য আমাদের এখন চিন্তা করতে হবে। জি,
থ্যাংক ইউ। আসসালামু আলাইকুম।
জি স্যার।
You have heard of counter current washing machine?
Sorry?
Counter current washing machine.
No.
Number of baths in the washing baths. So the water used in the first bath is kind of,
Yes.
the cloth is almost clean, you know. So that water goes to the second bath.
Second bath. Okay, count. Yes, sir.
So this is being used.
Yes.
It's nothing new.
It's good suggestion, sir. Thank you.
Counter current wash is common behavior in continuous dyeing process.
Okay, it's common
in Bangladesh. Yeah. Now fabric যাবে ওয়ান ওয়ে, তো ওয়াটার যাবে অপোজিট
পানি থেকে বিপরীত থেকে আসবে।
ফার্স্ট স্টেপ থেকে আমি প্রতি স্টেপে ওই পানি দিয়েই আমি ফাইনাল স্টেজ পর্যন্ত যেতে পারবো, অ্যাসিড বাথ পর্যন্ত। থ্যাংক ইউ স্যার।
Okay, thank you very much.
জি, থ্যাংক ইউ। আসসালামু আলাইকুম।
Now it's time for the analysis on the prospects of textile sludge utilization in energy and agricultural through hydrothermal liquefaction. Mr. Mahmudul Islam will present this topic.
Assalamu alaikum everyone. First of all, I'd like to take this opportunity to thank the Ictse 2024 committee for organizing such an event and also letting me and my team to present our a very recent research work, that is the analysis on the prospects of textile sludge utilization in both energy and agriculture domain through a particular thermochemical conversion method, that is hydrothermal liquefaction. This research is led by MD Rifat Hossain sir, including me as today's presenting author, Mahmoudul Islam, and the rest two authors are Shajnin Islam and MD Morshadul Haq sir. We all are from the Department of Environmental Science and Engineering, Bangladesh University of Textiles. So moving on to our outline for today's presentation. At first, we will showcase as part of the introduction, about certain background about textile sludge, also biochar, and a certain portion about the hydrothermal liquefaction method. Afterwards, our three core objectives. Then a brief methodology about how we conducted our whole project. Then in the resulting discussion portion, we will be comparing our obtained data with certain literature reviews and also the limitations we faced. And lastly, we will conclude through a summary and also the future prospects. While preparing this presentation, I came across two really fascinating and concerning data. That is, after today's conference ends, the world will be left out with 43 years, 220 days reserve of oil, which is one of the main primary source of our day-to-day energy, and 25 years, 220 days of food reserve. So why such a massacre situation? The consequence is such as due to the annual growth of population, which is 1.73% annually. That means the demand is raising day by day, but the supply that is declining, as 85% of the global primary energy is dependent on fossil fuels, which is declining day by day. And it's not like that after 43 years we will see the impact. Already around 20 million people of the world, around 0.25% of the population has lost the access to electricity due to the pandemic, inflation, and energy crises. In the agricultural field, the data is similar. We are annually losing 24 billion tons of fertile soil just because of unsustainable agricultural practices and also overuse of inorganic fertilizers. And concerning data is, within the end of this decade, the world will be requiring 45% more energy and 50% more food. So as a part of this solution, to find a solution, me and my team, a whole team, tried to find out a prospect that can enhance the lifespan of both of these resources. And we found out that in biochar. So biochar is basically a carbonaceous product that we prepared in an anoxic condition by treating through heat. And the basic properties that biochar consists is they have a great carbon storage capability for a longer period of time, which is handy in terms of energy production. Then they also have a better microbial activity and increased level of nutrient retention rate. That can be handy in agriculture as well, and also they have a greater impact on other agrochemicals. For example, fertilizers, they can increase the nutrient retention rate of fertilizer itself. Previously, many researches has been conducted in terms of the agricultural waste to prepare biochar from agricultural waste stream, for example, from almond shells, corn cob, rice husk, and namely etc. Sources. But what about other waste streams? What about industrial waste? What about textile sludge? Textile sludge can be a potential biomass because, let alone from Taiwan, annually 42,000 tons of textile sludge is produced. From Bangladesh, the number is 1.15 million tons of textile waste, and from China it is 21 million tons of textile waste. If we see the typical composition of a textile sludge that holds a pH of 6.4, it consists of 13.6% of organic matter and 80% of moisture. But a negative side is it also consists of various sorts of heavy metals. Previously, to produce biochar from the agricultural waste, pyrolysis has been a great technique. But what about textile sludge? Textile sludge consists at 80% of moisture, but pyrolysis requires a moisture that ranges around 10%. So we found out that hydrothermal liquefaction can be the exact thing. So hydrothermal liquefaction basically deals with the aqueous slurries within a temperature range of 300 to 350 degrees Celsius under a certain degree of pressure, which is more than water vapor, so that sort of hydrolysis process can occur and complex chemicals can be broken down into simpler forms. So the basic objectives of our research are, first of all, we tried to clarify whether the biomass that we selected, textile sludge, is suitable to produce biochar or not through proximate and elemental analysis. Then through FTIR spectroscopy, we tried to chase the suitability of the biochar itself, whether we can use it as solid fuel and soil amendment or not. And lastly, certain HTL limitations that we faced throughout the project. So the methodology is pretty simple. Here we first took obtained textile sludge from a polycotton dyeing industry, and we made a slurry out of it using distilled water and preserved it at 4 degrees Celsius temperature. And then we conducted the hydrothermal liquefaction process in a muffle furnace, where the operating conditions were the sample was taken 10 ml, temperature range of 300 degrees Celsius for 60 minute time and under 20 megapixel pressure. Then after taking out the reactor and cooling it down, we added dichloromethane in order to separate the phases. Then we also vortex the sample, and through centrifuge we ultimately get 3 individual phases, that is the aqueous phase, biochar and biocrude. We selected the biochar phase and done the further proceedings, which was FTIR spectroscopy. So in terms of the biomass characterization, the proximate analysis, we followed the ASTM D3172 process. Here is the whole process where we tried to measure the moisture content, volatile matter, ash content, and fixed carbon. And also we measured the elemental analysis through Vario microcube elementer. Then the FTIR spectroscopy was done through the ATR method, where we used Parkin-Elmer spectrum 2 model. And the main motive was to find out the functional groups and to analyze whether we can use it in the agriculture and energy domain or not. So coming to the result and discussion part, the moisture content was expected as it was 91.81%, but the important part is the last 3 composition, that is the volatile matter. We found out that the volatile matter is lesser than any other previous work, which is 7.44%, and that means that the low volatile matter can give a better biochar yield. Then the ash content, it was also even lower than the lowest that we found out in nutshell and fruit peel, that was 0.72%, and that means that we can get a higher calorific value out of it. And the negative part that we found out here, that the fixed carbon content was lesser in terms of what we reviewed from the other work. In the elemental analysis, we found that the carbon and hydrogen percentage is greater than 50%, that is accounts for 55.33%, which is really ideal for combustion. And it was also comparable with the lignite and peat materials. The biomass that we did the elemental analysis also found out to have a nitrogen content of 3.84%, that can promote the plant growth, and also a low sulfur content that can aid soil pH. Another great part is the HHV, the high heating value, which we found that it had 21.72 megajoule per kg, which was higher than rice husk, pine wood ash, or wheat straw. In the FTR analysis, in terms of energy, we found out that the biomass has hydrocarbons functional group that is great in terms of combustion, and also the aliphatic groups CH and CH2 within the range of 2850 to 2950. And in terms of agriculture, the presence of carbonyl bonds was there, which can be handy in terms of agriculture, as it is a prior bond for auxin groups, that is plant growth hormone, and also amine group was also found that can be handy in microbial processes. So the limitations that our work had is, first of all, we couldn't calculate the calorific value, as previous work that was done in the pyrolysis domain showed that a lower moisture content typically supports a higher calorific value, but as we conducted in the hydrothermal liquefaction domain, this needs further work. Then the biochemical composition was also not measured. It hinders the opportunity to measure that how a percentage of protein or lipid compound is there, and the biochar yield calculation was also not done while this research, and that hinders the commercial feasibility a bit. In conclusion, we can see that in terms of proximate analysis, we do have a low ash content that can boost calorific value, but due to the moisture content and hindrance of the biochar yield value, we can't be sure about, till now we can't be sure about the commercial assessment. Then in the elemental analysis, we have positive results, high carbon and hydrogen that is suitable for energy, and also a great nitrogen content that can be handy for soil amendment. And in the FTR spectroscopy, we found that aliphatic acid bonds are there, and also amine groups are there for nutrient support. And as part of the future directions, we can say that we have to conduct the elemental analysis of biochar to know more about the composition of our end product. We have to explore the co-HTL. We have to explore the co-HTL of our biomass textile sludge with other biomasses to check whether it increases the fixed carbon amount or not. And lastly, the heavy metal analysis and extraction process from biochar is also something that can be a pathway. That was all from our team. Thank you so much for your presence, and if you have any questions, you can ask us. Thank you.
Thank you very much, Mahmudul Islam, for your nice presentation. So you produce the biochar by hydrothermal liquefaction, right?
Yes, sir.
So is there any standard methodology? Did you use any standard methodology?
So we reviewed the past paperwork that used hydrothermal liquefaction from other biomasses like tannery waste or this sort of, and we followed that basically.
Okay. Any question, please, from audience?
Thank you so much for your presentation. So my question is that you have suggested one new ways of using slash in energy and agricultural sector. So as it is not yet been used widely, so which one is being used now commercially, and what will be the advantages and disadvantages in terms of money?
So as far as we researched, we found out that in commercial applicability, there are companies, they produce biochar from agricultural waste, basically, named Wastex. They take agricultural waste from farmers and other institutes, and they produce biochar out of it, and they even give them advantage of carbon credits as well. So in the textile sludge arena, there are no such commercial aspects, but ultimately we are trying to get there through this research.
Because the farmers should use your product and it should be cost effective.
Yes.
And unless your product is not cost effective, nobody will use it. So you must think about the costing.
Commercial,
and because I have seen so many reactions are there, So how much feasible is it to use in Bangladesh, and how you will take the sludge from the textile industry, and there are so many transportation issues.
Yes.
So you must always, whenever you develop a new process, so then you must compare with the present process, present product, conventional product. So you must compare. So I think you have been compared that
So
one.
yet not, but we
Yes.
are on the process.
So I think you will also compare it, and hope it will be helpful for the agricultural sector in Bangladesh. Thank you so much.
Thank you so much.
You have talked about waste from textile sector, okay?
Yes.
Dyeing section, okay. It may contain various types of chemical.
Yes, ma'am.
So have you considered it?
Various
Types of chemicals, so it can create hazardous situation, may cause air pollution or particulates matter.
Ma'am, as
Have you addressed this?
no, ma'am, not yet.
Thank you.
Usually textile sludge is used in the cement industry.
Yes, sir. As being
So,
in the paper
yeah.
industry.
For the agricultural purposes, if you want to use, so I think it remains some toxic substance.
Yes, sir.
You have to remove it.
Sir, as I mentioned in the future directions, the last point, the heavy metal analysis, so we found out that there was this agricultural waste, sunflower, from which biochar was produced, and it had heavy metals as well. So they converted it through the hydrothermal conversion method, which is similar to HTL, and they used hydrochloric acid while the process, and that transferred the heavy metal from its body to the aqueous phase. As I mentioned, there are three phases: aqueous phase, the biochar, and the bicrude. So the heavy metal gets transferred in the aqueous phase. So this is the direction that we can go forward to separate them.
Okay. Any questions? Any?
I have a question. That is, the sustainable development goal. One of our sustainable development goal is less carbon dioxide emission, and you produce here a biochar by combustion method, right?
Yes, yes.
And do you maintain the procedure, the sustainable development goal procedure, and have you account the carbon dioxide emission?
So it is a carbon neutral process. As carbon neutral process, so it won't be that much. The issue that you are mentioning, it won't matter in detail.
Have we account some?
Yes. Sorry.
Have we account the carbon dioxide emission?
No,
Count?
we didn't count it yet, but as we know that the proceeding of carbon neutral, it already exists or comes from the environment. So we are releasing back into the environment doesn't make that increase in the carbon content.
Okay, thank you.
Hello.
Hello.
Sometimes in the sludge are fluorinated, chlorinated dyestuff residuals.
Yes.
How to interfere it with the charcoal production?
Sorry, sir, I couldn't.
If you have some problems with your charcoal production because of the fluorinated, chlorinated products in the sludge?
Sir, the
He's talking about fluorinated charcoalation. Have you any idea about it?
not yet, ma'am.
Hello. In textile sector, huge amount of sludge we collect. Sludge management is still now difficult for us. For this reason, we are not suggest to go to the landfill, secured landfill, not brick fill. Now, most of the factory are used to give their sludge to Lafarge Holcim because there are incineration, high temperature. And in your concept, how you will manage the MRSL? That is, I mentioned earlier, speaker permitted carbon. How will you manage the MRSL and ensure that in your process, how will ensure the MRSL are controlled? That is more important. Yeah.
Sir, yet yet we didn't thought that much. We are just on the primary stage of analyzing whether it is a great biomass to move forward or not. That's why I can't answer you right now about this one, but definitely we have all this in our mind to proceed further about it.
Because the sludge is very good fertilizer. We can easily use it in our own fertilizer system, but we don't do this because of MRSL control.
There is a tag that we are using the HTL method, and as we are burning the sludge into a certain temperature and certain process, we are not directly using the textile sludge to the agriculture product. So we will definitely have further proceedings whether the HTL do have an impact on the things that you are mentioning or not. Yeah, that's all.
Thank you.
Excuse me, just I want
yes, sir.
to clarify, First of all, I would say that this disposal of sludge is a very serious problem about textile.
Yes, sir.
And something should be done
about it.
So it's a good piece of work, at least the effort you are making.
Thanks.
But I wonder what is actually happening. It's some kind of carbonization. You said biochar.
Biochar, yes, sir.
Simple carbonization.
Yes, sir.
And that carbon can be used as the fuel for burning purpose.
Yes,
is it?
So it is mainly a hydro.
And the other part can be used as a fertilizer for the land,
So it is a part of a kind of hydrolysis process, where in a water medium we are
just hydrolyzing, but you are producing chars, which is solidification.
So I tried to mean that in the HTL process, it is a kind of hydrolysis process where in a water medium we are degrading or breaking down the complex chemical compounds into simpler forms.
It's like coke making, from...
Yes, sir. We can use it as co-firing with coke.
Yeah.
Okay. Thank you very much for your presentation. Yeah.
Thank you.
And this is the final presentation today. The topic is biological treatment of textile wastewater by using domestic wastewater as a co-substrate. And MD Bashirul Islam will present this topic.
Assalamu alaikum. Muhammad Bashir Islam. First, I thank to give me the opportunity to present my work, biological treatment of textile wastewater by using domestic wastewater as a co-substrate. First of all, I want to say that I work on 3 wastes: textile wastewater, domestic wastewater, and fecal sludge. First, I want to say about textile wastewater. It is produced due to industrial activities and urbanization, and it is increased day by day. In 2016, the amount of generated textile wastewater 217 million cubic meter, which is increased in 2021 around 349 million cubic meter, which is a major source of environmental pollution when we release to the environment. Another wastewater is domestic wastewater, which is also produced from urbanization. Bangladesh generates an estimated 5,326 million cubic meter domestic water annually, and 1.2 million cubic meter of septic sludge annually. In this, we consider domestic water at nutrient source and fecal sludge at a food microgram source for this analysis. We use biological treatment, anaerobic treatment, and co-anaerobic treatment, which have many benefits, including dilution of toxic substances, nutrients balance, synergistic effect on microorganisms, economic benefits, increasing organic loading rate, higher methane yield, and unit of digester volume. So, main objectives I have set in my work to investigate the biological treatment of textile wastewater through anaerobic cogeneration with domestic wastewater, utilizing fecal sludge as an inoculum. There are various parameters for different residence time with different mixing ratio, and some suggestion post-treatment based on the test results. As the methods, left figure indicates schematic diagram of laboratory setup. We collected textile water from outlet of the textile industry from Circularity and collect domestic wastewater and fecal sludge from a septic tank of a student hall at Chuet, and we feeding the flux, aluminum flux, with total 500 milli with the ratio of 0%, 25%, 50%, 75%, 100% textile wastewater with domestic wastewater. And we inoculated 30% fecal sludge with the feeding with the 500 milli wastewater. And then we adjust pH at 8, and the reactor are incubated at 37 degrees Celsius for 6, 10, and 14 days. As the initial parameter that I've measured, here we saw that domestic wastewater more color, nitrate, ammonia, phosphate values, COD values than textile wastewater. Then result and discussion. Left figures of pH variation. pH slightly varied, 8 to 9, with the residence time, which indicate alkaline condition of the various reactors, and which also indicates produced methane through methadonis process. Increase in pH 8 to 9, which is due to the methadonis process, and right figure indicates EC, electrical conductivity, which initial increase on day 6, which indicate that conversion of organic matter into simpler organic compound, especially volatile fatty acid. Then color and turbidity removal. The left figure indicate color removal, right figure turbidity removal. Both figure indicate that at the 10 significant amount of removal was found. This removal at day 10 indicate that the moderate resistance time are favorable for removal of color and turbidity in the coanaerobic digestion process. In previous study also found that resistance time 9 days for anaerobic co-digestion of textile and domestic wastewater. And here also we found that lowest value of color 720 platinum cobalt unit, which is higher than Bangladesh Environment Convention rule, that indicates post-treatment are required. As the variation of nitrate and ammonia nitrogen, which indicate that initially increase nitrate ammonia, then decrease afterward after day 10 residence time. That's indicate that initially increase the initially increase the ammonia that due to the ammonification process, and then decrease with residence time due to the reduction of due to the methadonic activity and denitrification process occurred in the anaerobic reactor. Then phosphate and COD removal. Phosphate also saw the similar pattern, initially increase then decrease. Initially increase at day 6 due to the rapid growth bacteria breaking down more organic matter and releasing phosphorus. And later days, phosphate accumulating organisms take up and store excess phosphorus in their cells for the activity and growth. So phosphate are reduced. And we saw that right figure, COD removal, which increased at maximum at day 14 and significant increase at day 10. But which indicate high microbial degradation of organic matter, but still lowest COD value, 250 milligram per liter for 100% textile wastewater, exceed standard limit. So indicate post-treatment are required. So conclusion is that the varied results are found in our study, and color, turbidity, and COD saw similar patterns and removal efficiency with the maximum removal observed for 100% textile wastewater. In contrast, other parameter PA, CC, ammonia nitrate, phosphate, nitrate nitrogen, fluctuation, solid fluctuation both increase and decrease in residence time. So some recommendation is that some post-treatment is required to discharge the wastewater to the environment, and it also recommended that explore different sources of domestic wastewater. Only here we saw that only septic tank wastewater we used, but it is still an opportunity to show that different sources of domestic wastewater, and inoculum can be changed for effective solution for this treatment process. It's also explored that interesting result in our work, 100% textile wastewater with fecal sludge can be used in AVR, anaerobic vapor reactor, with a different residence time to improve the efficiency of the current study. That's all. Thank you.
Thank you. Thank you very much, Mr. MD Bashirul Islam.
Yes.
So you use the biological treatment for textile wastewater by using domestic wastewater as a co-substrate.
Yes.
Right? So domestic wastewater, how can you use as a co-substrate? As a co-substrate, how can you use this?
With different ratios with textile wastewater.
Can you show the PPT again? And what about the result?
Wastewater was mixed with initial first line. Textile was mixed with domestic wastewater, totaling 500 milli with 5 different ratios.
And you use the different ratios, right?
Yes.
Okay. Any question, please? Any question from audience? I think everyone are tired. So we don't have enough time. Okay, thank you very much. Okay, thank you very much. So now concluding remarks. Our chair, Professor Dr. Nargis Jahanara, will say something, and that's all for today.
Okay. I would like to thank everybody for staying with us. Especially, I would like to thank Dr. Mustafizur Rahman, who is ex-principal of this institute, college, during college period. And special thanks to guests coming from abroad, and also for a speaker who make it interactive and interesting. I hope I will see you in coming future. So stay safe. Have a great day. Thank you to all.
So thank you so much our session chair Professor Dr. Nargis Jahan Ara, and also co-chair Dr. Sheikh Muhammad Mamun Kobir. Thank you so much for your all the efforts, and I hope that is our audience has enjoyed a lot. Now we have a 20 minutes break, but before that I just want to mention you we have another session, technical session 5, which will start just after the break. So the break will be for 20 minutes, so we will start again at 4:20. So there will be another session, and I really invite you to join. Now we have snacks outside, so please enjoy the snacks and coffee, relax and come back again. And the next session, those who will present, please contact with the volunteer team. Please enjoy your snacks and coffee, and then come back for session 5.